Lesson 8.4, the equation of a sinusoidal function. This is pretty much approaching the end of the year, the last kind of content you're going to need to know. What we're going to do is look at how to change the characteristics of a sinusoidal function. So here's a pretty fancy looking equation. What I want you to do is look at these individual parameters, A, B, C, and D value. And we're going to do this with a sine graph for the most part, but the cos graph, things are exactly the same. So we're going to try and change those values and see how that affects the graph. Okay, so if you look at, this is our basic sine graph. This is just y equals sine of x, where a is 1, b is 1, c is 0, and d is 0. Okay, this is the basic graph. What we're going to do first is see what happens when we change the a value. So as I said in this first one, a is 1, but then we're going to put a different value in for a. Now the rest of the graph is the same. What we want to do is see how does a change the graph. Okay, so I'm going to go to y equals here, and what I've done is I've entered those values in: sine x, 3 sine x, negative 4 sine x, and then a half sine x. And I'm going to go zoom trig. Okay, so this is the first graph. Now the second one, how is it different? Well, instead of having a 1 in front, it has a 3, and then a negative 4, and then a half. How are the graphs different? Well, you can see that the amplitude changes. Okay, so we're going to quickly sketch just one period of each one. This was our regular sine graph. This was 360 degrees, 180, 90, 270. Okay, and it went up to 1, down to negative 1. All right, if you look at the second graph, how is it different? Well, looking on the graph, it's going to look very similar, except that the amplitude will be greater. This is going to go up to 3 and down to negative 3. Okay? And then what is the next one? The next one is negative 4. Well, just a quick comment on that negative. If I went like this, just put 4 sine of x, the graph would look like this. It would just go a little bit higher. Okay, but it's not 4, it's negative 4. So what happens is it actually flips upside down. Okay, and it goes up to 4 and down to negative 4. All right, and then the last one we have is a half x. So instead of going up to 1, it's only going to go up to a half and down to negative a half. Okay, so those are the 4 graphs. Let's answer a couple of questions it says here. How are these graphs similar? Well, they have the same period. Okay, and we should quickly talk about period. In the case of all 4 of these graphs, the graphs is in 360 degrees, but that's degree mode. If we would do the graph in radian mode, then instead of 360, it would be 2 pi. Okay, so we have to remember that the graph will look the same, but the scale will be different. Okay, and how would you change that? Well, if you look at my graph here, you can't tell whether it's radians or degrees, but you go to mode, and you can see I have it in degrees. If I change it to radians, okay, and then I go zoom trig, it automatically adjusts, and the graphs will look identical. The only difference is going to be if you look on the scale of the graph, they're going to have different values for the x coordinates. Okay, so these graphs, they have the same period, and we'll say 360 degrees or 2 pi. How are they different? the amplitude. Okay, what is the connection between A and the shape of the graph? Well, A is actually the amplitude, or vertical stretch. It tells you how far up and down the graph is going. So if you looked at the first one, where we had a 1, this is y equals 1 sine x. The amplitude is 1. This graph, where it was y equals 3 sine of x, the amplitude is 3. The one where it says -4, the amplitude is 4, not -4, +4. Okay, and so the amplitude is just the value of A. All right. Positive value as opposed to a negative value, this is just going to flip it upside down. Flips the graph upside down. So if the graph looked like this, then flipped would look like this. Okay? So that's what we call the first parameter. The parameter B, so now we're going to look at the value of B in this equation. Okay, we're going to keep A, C, and D the same, but B is going to change. Here B is 1, here it's 1/2, here it's 2, and here it's 6. Okay, so we're going to go and do the same thing on the graph. We're going to change all of these values. Okay, so we'll leave the first one as sine x. The second one, we're going to go sine, and then you could put 1/2 or 0.5, it doesn't matter, but 1 divided by 2x. And notice I'm not closing a bracket. I mean, you can put that closed bracket there, it doesn't matter. Won't change anything. Okay, and the next one is sine 2x. And then sine 6x. Okay, and we'll go zoom 7 again. So you can see there's the first graph. And then there's the second graph. There's the third graph. And there's the fourth graph. How are those different? All right, well, let me give you a quick sketch here. So this is, again, the original graph. This is just sine x. And I'll write 90, 180, 270, 360. Goes up to 1 and then -1. And then we want to look at how is this one different. Okay, well, this one, if you look at the graph on your calculator, will look like this. Okay, and I'm looking at only that one little section here. It actually continues back like that and would go like this, and it would come back here at 720. Okay, and then we have this one. This one's going to look like oops, missed it by a little bit. There, I'm going to leave it like that. And I'm not going to draw the last one in. You can just see that that one happens much more frequently. Let's talk about how are these graphs similar. Okay, this one has the same amplitude. How are they different? The period is different. What is the connection between B and the period? Well, this is a little bit tricky. The amplitude, if the A value was 3, the amplitude was 3. The period, on the other hand, it is affected by B, but we divide instead of multiply. Okay, so in this case, we take the B value and we divide 360. So let me just look at one example here. Okay, let's look at the green graph. the green graph, b value is 2. So you would go 360 divided by 2, and the period is now 180. In other words, this green graph repeats in a period of 180 degrees. Okay? If you look at the black graph, why did that one look so strange? Well, if you go 360 divided by a half, you end up with 720. So the period for the black graph is 720. Okay, so how are b and the period related? You take 360 or 2 pi and divide it by the value of b, and that will give you the new period. Okay, so we'll wrote that here. All right, let's go and do the third parameter. The third parameter is c, and it is what we call the phase shift. In other words, we're going to move left or right. Okay, and this time I have to do them in degree and radian because it'll look different on the graph in this case. Okay, let's stick to degree mode because that's what we've done so far, and we can quickly sketch in. Here is our regular sine graph. Okay, and then this one is 45. So let's try and put that on the graph. Let's go to y equals, we'll leave the first one, and we're going to write sine x plus 45. Okay, and then the next one, we're going to write sine x minus 90. And then sine x minus 60. And let's go zoom trig on those. So there's our first graph. There's the second graph. And the third graph. And then the fourth one. Well, what the heck? What is the difference here? Well, you can see that the amplitude is going to be the same for them. In fact, the period is also the same. But what does this 45 degree do? It actually moves it backwards 45. Okay, so this is going to be 135. So we have a graph that has just moved backwards 45 degrees. This is 315. Okay, so then take a guess. What do you think is going to happen here? If we had to go back 45 for the last one, what do you think we're going to do with that 90? Well, in this case, you're going to move right 90 degrees. So take the green graph. Okay, look at, I'm going to take these 5 points, and I'm going to move it right 90 degrees. So this one would go here. This one would go there. Oh, I was supposed to use black, sorry. I'm going to take this one and move it here. I'm going to take this one and move it 90 degrees that way. This one 90 degrees this way, and this one 90 degrees here, so it'll be at 450 degrees. And so this graph will look like that. Okay. Number 4. It would move right 60 degrees. We'll leave that one for now. Okay, I'm going to show you how this graph is identical, but now we're at 2 pi instead. Okay, so that's your original graph, and then it asks us to move it right 1.6 units. Well, this is a little hard because we don't have 1.6 units anywhere here. But you should know that pi by 2, if you go pi divided by 2, this is 1.57. That's pretty much 1.6. Okay, so what we're going to do is take each of these dots and move it to the right 1.6 units. So it's going to be about there. If I go this far, it'll be about here, 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 and here. Now what is this unit? This is 2 pi plus 1.6. Okay. So it looks like that. Let's try this one. This one says go right pi units. So we're going to take all of our dots and move it that far, pi units. So our first dot would go all the way to here. Our second dot would go all the way to here. Our third dot would go to here, and then to here, and then to here. This is going to be 3 pi. Okay, so what effect does C have on the graph? It moves left or right. Okay, the shapes of the graph remain the same, the amplitude is the same, the period is the same, but the graph moves. And it's kind of like the opposite, moves the opposite to the direction of their sign. So if it was a positive number, we moved left. If it's negative, we move right. Okay, that's called a phase shift. The last parameter, the vertical shift. Okay, let's start with our basic graph. Now, if you ever get stuck on what these values are, you could always plot it in your calculator and it'll give them to you. Okay? So we're supposed to look at what happens in each of these cases. So let's go back to y equals. Again, we'll leave the first one. The second one, we're going to go sine. Now, you got to be careful here. Sine x, close the brackets, plus 2, because we want this to be outside the bracket, not inside. Then we're going to go
Mr. Shapiro to the attendance office, please. Benson Shapiro to the attendance office.
sine x, and then we're going to go close brackets, minus 4. Okay, and then sine x, close brackets, plus 5.5. And then we'll go zoom 7. Okay, there's our first graph. Uh-oh. What did I do wrong here? Oh, there's an extra bracket there. Hey, look at that. What's happened to the graph? You can see that this time the amplitude is the same, period is the same, but what has happened? Well, in this case, the graph has moved up 2 units. So we're going to take all of our points and move them up 2. Again, which points are we going to take? These 5. They're kind of like the important points. So if I go up 2, that will be there. This one will be at 3, 2, 1, and back to 2. Okay, so if I were looking at what is this point, this is 360, 2. What is this one? 270, 1, etc. If I want to look at this graph, I'm going to go down 4 units. So each point is going down 4 units. So I'm going to go way down here. There, 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 there. Okay, now if this was ever a test and you graphed that, you would have to give me a little more information. You would have to show me that you know this is 360, negative 4. This is 270, negative 5. etc. Okay, so what does D do to the graph? Moves it up or down. Okay, they were all shifted up or down by D units. We call them a vertical shift. Does not affect the period, does not affect the amplitude, just moves it up and down. Okay, so here's what I would like you to do. I think you can probably do this without actually graphing it, right? If we take our original graph, I'll just fill out the first little bit for you. What is the maximum of your basic graph? Well, here's our sketch. Okay, and you should be pretty comfortable with this already. This one goes from max 1, min -1. The amplitude is 1. The period is 360 degrees, or in radians 2 pi. What is the change? There's no change. This is sine of x. Okay, so now what do you do in the second graph? What does this plus 2 do? That's going to move it up 2. How can you tell? Well, it's not in the bracket. So the maximum if I go up 2, the minimum if I go up 2, the amplitude still 1, period doesn't change because if it moves up or down, this doesn't change it. Okay, I'm just going to say up 2. You can say vertical shift of 2 units up, but you don't need to. Okay, and so the graph will look something like this. Okay, and you would have to plot in some points here for me. That's kind of an ugly graph. Okay, so if it shifts up 2, this is 2. This is 93. This is at 182, 271, and this is 362. Okay, so go ahead and try this for homework. That'll be it for this lesson. Okay, you should just get used to how do these graphs move up and down. Okay, lots of homework to do here. See how far you can get. The more you do of these, the better you'll get at it.